Now we've got Newton's temperature problems. So let's say the rate of change, well, let's save this because it's true. The rate of change of the temperature of an object immersed in a medium of constant temperature, different from the temperature of our object, denoted as T sub m, is proportional to the difference between it and T sub m. So T sub b is going to be, you're going to subtract T sub m from T sub b. K is our proportionality constant. Nope. And T sub m is actually constant. Okay, so the medium, you could say it's immersed in like water. I suppose like room temperature would also work. You know. Regardless though, so yes, here we go. Change in temp of observed object with respect to time. Proportionality constant. Temp of observed object. Temperature of medium. So okay, yeah, here's the thing though. We do need initial conditions. It's crucial that we get those initial conditions. Otherwise, we won't be able to solve this. And we need to find the temperature of our immersed object after some time t. Okay, so we actually need two conditions. Cool. An object whose temperature is 200 degrees. It is immersed in a liquid, which is kept at the constant temperature of 50 degrees. In 1 minute, the immersed object's temperature decreases to 170 degrees. How long will it take for the object's temperature to decrease to 100 degrees? Okay, guys, this is pretty sweet. First things first is we put this guy in, our constant here. It's immersed in a liquid of 50 degrees. The first thing you want to do is you do want to figure out what your constants are, analyze, observe, and we have discovered that. So now there's less garbage for us to play around with, and we only have one t, which makes it far less confusing. But now we do have two variables to solve for, t and k. Okay, so we know that we can bound our integral. First of all, this is a separable equation. We can bound our integral from 200 to 170 as it is decreasing. Okay, remember that it is decreasing, so 200 to 170. It is decreasing. And that is equal to 0 to 1, negative k dt, because in 1 minute it decreases from 200 to 170 degrees. I love the logic behind this, and definite integrals, wow, incredibly important in all scenarios. It's just kind of genius that we could just do this. Sometimes I just think that. Anyways, let's continue. This all teeters out to natural log of 4 divided by 5 is equal to negative k. So k is equal to the negative natural log of 4/5. So now all we need to do is figure out how long will it take for the object's temperature to decrease to 100 degrees. So this just becomes a regular problem, and and we have an initial value. We want to find out how long it will take to decrease to 100 degrees. So not an initial value of time, but an initial temperature value. So 200 to 100, solve this, 0 to t, because we're going to solve for t. Natural log of 1/3 is equal to negative t multiplied by the natural log of 5/4. T is equal to the negative ratio of natural log 1/3 over natural log 5/4. And you get t is equal to 4.92334 minutes. And that is the solution to this problem.